here, section 2.2, day 3 homework. And we are now graphing these guys. We're going to use our leading term test, the zeros, and the multiplicity to decide whether it bounces or crosses. So the leading term for this guy, remember I said that's x times x, all the leading terms of these guys, times x squared, which means it would be x to the 4th. That's a positive even function, which means it's going to have end behavior where we go up at both ends. In other words, it's a parabola-ish shape where we go to positive infinity on both sides. My zeros then are x equals 0 with a multiplicity of 1, x equals -4 with a multiplicity of 1, x equals 1 with a multiplicity of 2. So I've got something happening here at 0, at -4, 1, 2, 3, 4, and positive 1. So with any luck, I should be able to connect these arrows. So at -4, my multiplicity is 1, so I'm going to cross. At 0, my multiplicity is 1, so I'm going to cross. At 1, my multiplicity is 2, so I'm going to bounce. Oops. All right, so it doesn't quite look like that on the end, but you get the idea. If I was graphing it for a quiz, though, I would probably want it to look more like this, and I might even make this look a little bit better like that. There we go. All right, for number 2, my leading term is x squared times x times x. That is also x to the 4th, which would be an up parabola, upward facing parabola. My zeros this time are at 0, where I'm going to bounce because it's even. At 4, with a multiplicity of 1, so it's going to cross. And at -2, again, multiplicity of 1, so it's going to cross. So my zeros are at 0, positive 4 this time, -2. I'm going to start high, I need to end up high. So starting high, at -2 I cross, at 0 I bounce, at 4 I cross, and I end up high. So we did it right. All right, number 3. All right, for my leading term here, I've got -2 times x cubed. That'd be -2x to the 4th. It's an even degree, so it's going to be parabola shaped, but this time it's negative, so I'm opening down. My zeros, be careful, there's no x out here, so this is not a 0. That's just shaping our leading coefficient. I only have 2 zeros here. X is equal to 3 with a multiplicity of 1, so it's going to cross there. And x is equal to -2 with a multiplicity of 3. It's going to cross there as well. So we're going to start low, we're going to cross 2 places, and we're going to end low. So we've got a crossing here. Whoops, that's -3. I want -2. And 1 out here at 3. And we are starting low here. We are going to cross at -2, cross again at 3, and we end low. Work 12. For number 4, my leading term is -x times x squared times another x squared, which would be -x to the 5th. Finally, something that's not a parabola. It is an S shape. Because it's negative, it's going to be a decreasing S shape of some kind. My zeros are at 0 with a multiplicity of 1, so we're crossing. At x equals -2 for this guy, it's got a multiplicity of 2, which is even, so we're bouncing. And at x equals 4, again, multiplicity of 2, we're bouncing there as well. So here we go. We got 1 at 0, -2, +4. We're going to start high. We need to end up low if we get it right. So starting up high, at -2, we are bouncing. At 0, we are crossing. At 4, we are bouncing. And we end down low. That's kind of a pretty looking thing. All right, looking onward to number 5. This is back to the ones like we did yesterday where you actually have to factor it yourself. So for this one here, based off of my leading term test, which just means looking at that guy, I'm going to have an odd function that's negative, so it's going to be a decreasing odd function. It should look something like that. To find my zeros, what do these guys all have in common? They have a 2 in common, they have an x in common, and I'm going to go ahead and pull out that negative, which leaves me with positive x squared, like I like to factor, and then positive 2x, and then minus 3. We are looking for 2 factors of 3 that subtract to 2. My only 2 factors of 3 are 3 and 1. I need it to be a positive 2, so I want positive 3 minus 1. All right, so for my zeros, I've got x equals 0, multiplicity of 1, it crosses. X equals negative 3, multiplicity of 1, it crosses. X equals positive 1, it has a multiplicity of 1 as well, so it crosses there. We're going to start high, end up low. We're crossing at 0, and negative 3, and positive 1. So starting up here, crossing, crossing, crossing. There you go. Feel free to be even more creative than that on your test. By that I mean you could make this function. It could look something like this. If you wanted to get real creative with it. Just as long as I can see where you're crossing your x-axis and where you're ending up on either side, you should be good. All right, finally for f of x is equal to x to the 5th plus 3x to the 4th minus 10x cubed. It is a positive odd degree, so we're going to start low, make an S shape of some sort, and end up high. For my factors for this guy, only thing I have in common is this x cubed. When I pull that out, I've got x squared plus 3x, and then minus 10. Let's do this work down here. All right, so I've got x cubed. I'm looking for 2 factors of 10 that subtract to 3. That would be 5 and 2. I need it to be positive 3, so I need a positive 5 and a negative 2. So my zeros would be x is equal to 0, multiplicity of 3, that's odd, we cross. X equals negative 5, multiplicity of 1, odd, we cross. And x is equal to 2, multiplicity of 1, odd, again we cross. So here we are at 1, 2, 3, 4, 5, negative 5's out here, 0, and 2. Start low, end high. So starting low, going to cross, cross, cross. And we end up high. Looks good. All right, for 7, 8, and 9, this time they're going to tell me the zeros, and then I have to write a degree in polynomial with these zeros. So for this first one, my only 0 that I have is x minus 1. Be careful. That's your 0. What's the relationship between my 0 and my factor? Hopefully you're saying it's the opposite sign. So if this is my 0, my factor would be x plus 1, and it has to be degree 3, so that would be 3 up there. For 8, let's call this one g of x. I've got 2 zeros, which means my 2 factors are x plus 5, x minus 4. It needs to be degree 4, so all total I need to have 4 x's. You could say that it's 2 and 2, or you could choose to be 3 on this one, 1 on this one, or you could choose to have 1 multiplicity here, 3 multiplicity here. It doesn't matter. All 3 of those would be correct, acceptable answers, whichever one you want. For number 9, I've got 3 zeros, so I've got x minus 2, x minus 1, and x minus 4. I've got 5 degrees, so I can play this however I want to. I could do 2, 2, and 1. I could do 1, 1, and 3. Any order you want, completely up to you. All right, number 10, decide whether the degree of the polynomial on each graph is even or odd. We're ending up both on sides, so this is a parabola-ish shape, so this would be even degree. We're Whereas this one over here is an S-like shape. I'm starting low, ending high. If they end on the same side, it's an even degree, otherwise odd degree. Be careful, that's not an odd function, it just means an odd degree function. Since we're opening up, my A sub n, which is my leading coefficient, is positive. Since I am increasing throughout, again, my A sub n is positive. So there's section 2.2 homework solutions for day number 3. Good luck on your quiz tomorrow, guys.